All right, so last week we were messing around in section 2, which is what does it mean to be a fraction? How do we define it? How do we model fractions? Ideas about reducing fractions and growing fractions, expanding them. And now we're going to play with operations, addition, subtraction, multiplication, and division. And there's activities about that. So we're going to work on the addition and subtraction stuff today. So that's activity 5.3a. And then homework 5.3, addition and subtraction of fractions. And the next class will focus on multiplication and division. Let's see, we have some more guests. We have Lauren and Julian. Welcome, good afternoon. I hope it's a beautiful snowy day where you are. All right, so more fun with fractions. So important things here to continue is what does it mean to be a fraction? And there's many definitions, there's many interpretations of what a fraction is. The one that we come back to more than anything is related to equal parts of a whole. And so what I hope we're gonna do today are take ideas about how we modeled addition of whole numbers, subtraction of whole numbers, multiplication and division of whole numbers, apply this idea of equal parts of a whole along with what addition, subtraction, multiplication, and division mean, and come up with strategies, algorithms for how to add, subtract, multiply, and divide fractions. So a couple of examples of equal parts of a whole. The easiest one for me to draw, for example, if I wanted to make, say, 1/3, would be to just draw a rectangle, maybe a square, do my best to mark it into thirds. That looks fairly close. And then select one of those thirds. So maybe this one right here is going to be my 1/3. Now, we came up with other ways to do that too. So there were the pattern blocks that we played with last class. There are just those color tiles we could play with. And then the color rods we could play with. So some of those are going to be useful. I accidentally posted a link somewhere to a version of the pattern blocks that the app is out of date. So let's make sure I've got the right one here in the activity. So we have the color strips toy, that should be the same one we played with last week. Yep. And then hopefully this is the right version. No, that one. Okay, so I accidentally, so again, there's a lot of different versions of this. This one is based on an application called Flash from Adobe, which is no longer used in browsers because it's a security hazard. So I need to fix that link right now. Sorry about that. And on the resources page should be the right one. So if you see that I posted a link to an app that's busted, let me know. Thank you. I think it was Amanda for letting me know about that one. Okay, the Math Playground one works nice. No, sorry, the Math Learning Center Playground is broken. So we'll be using this today. Let me just fix this link for y'all. Do it. So if somebody else out there in class could do me a huge favor, get on over to activity 5.3a, fraction addition models, and down to part 2, and make sure this works for you too, that when you click that online toy, it takes you to the Math Learning Center instead of the Math Playground. Cool. Let's see. Evan is back, and Amanda is here. Hey, Amanda. So these are some other toys that we could play with. So if I say that's one whole, then my claim is that piece there is 1/3. So let me grab that into my screen. So here's another way with a different set of toys. Instead of drawing my own picture, my claim is this one right here is 1 whole. So then this blue piece right here is 1/3 of the whole. because I can lay some more of those blue pieces down to see that 1, 2, 3 of them make up a whole. So one blue piece is, again, 1/3 of the whole. And there's lots of evidence out there that when kids get physical, when they're trying to learn this stuff, and that's holding stuff and manipulating it with their own hands, they get a better grasp of the mathematical concepts that are going on. So drawing it like this is important, and holding these things and messing around with them is also important. Chat, it worked. Thank you, Amy, for checking that out for me. I appreciate it. So we're just going to play around today with what is a fraction and what does it mean to add and subtract. And then from there, we'll generate some algorithms. So let's get busy. So let's start with a nice, easy example. We'll first look at it by drawing, and then we'll play around with the toys. So I want to figure out what is 1/2 plus 1/3. And to do this, there's two things I have to do. I have to answer a couple of questions. One question is, what is a fraction? The second question I have to answer is, what does it mean to add? So what is a fraction? Well, that in this case is going to be an equal part of a whole. And what does it mean to add? To add means, if we think way back to whole numbers, it means to combine some stuff and then count. How much do you have? So combine and count. So we're going to illustrate what a half looks like, what a third looks like. And again, my opinion is the easiest way to illustrate either of those is by starting off with some kind of square rectangular cake. Make as close to identical one as you can for a third. All right, so those are as close to the same size as I can make them at the moment. And one of them I'm going to split vertically, so there's my halves, and the other I'm going to split horizontally to get my thirds. And then I just want to shade one of those halves and one of those thirds. So a naive answer here would be to say, hey, 1/2 plus 1/3 is 2 pieces. I got 2 pieces of cake. Okay, sort of, but the pieces aren't the same size, right? So we would fight about who gets the bigger piece. So that's not good enough. I got to go farther than that. When we count stuff, we want those things to be like. So I need a like description for them, and I don't have that yet. Okay, so just make a little note. Problem. Pieces aren't the same size.
Wouldn't it be easier to draw them like with the lines the same way? That would show you the differences of the fragments within the whole if they were like the same symmetrical, cut the same way, like the 1/2 and then the 1/3 cut down instead of across, or am I missing something?
No, so the reason I cut them in different directions is in order to make them equal size pieces, I cut each like the other. So that's the solution to this problem, at least one solution.
Okay, thanks.
Yep. So if I take the thirds and like the half is cut vertically, I do a vertical half cut there. And then for the half, I mark the thirds horizontally. Now they're each cut like the other. So I renamed each piece. So instead of 1/2, this is 1, 2, 3 out of 6 pieces. And this one right here is 2 out of 6. So now they're the same size pieces. So what do I have all together? Well, all together there are 5 pieces. And those pieces are 6 because there's 6 parts of a whole. So I have all the same size piece now. I can now count them up. I can combine them and count them. And I can only combine and count them if they are the same size, because fractions have to be equal parts of a whole. And until I recut each, I didn't get equal parts of a whole. And so with kids, we try to practice this in a bunch of different ways. So I'm going to do the same example, but with my toys now. Stop share. Okay.
I just had to share, Gary, that
Yeah.
this is exactly what my daughter's doing in math right now.
Oh, cool. Excellent. So here I've got some pieces, and so I got to establish what is a whole. So one of these hexagons is going to be my whole. I'm just going to leave that at the top. And then I want to show what a third looks like. So that's a third, and if any kids weren't convinced it was a third, then we would put 3 of them on top there and say, look, okay, 1, 2, 3 of them make a whole. So one of them is 1 out of 3, or 1/3. And then for my half, I can bring in that red trapezoid, and for most kids, it's going to be pretty clear. Oh yeah, that's half. And just to double check, we can say, here, look, we put 2 of them there, they make a whole, so one of them is 1/2. What do I get when I put them together? Well, when I put them together, I get a red piece and a blue piece. No, we need a better answer than that. I get 2 pieces. Yeah, I got 2 pieces, but that's still not a good answer because they're different sizes, okay? So then we have to say, all right, well, what else can we do? And we've got these beautiful green pieces we can play with. And it turns out 2 of those green pieces make a blue piece. And 3 of the green pieces, these are light and foam and sometimes hard to handle. All right, there we go. 3 of the green pieces make the red piece. So I throw them on top of each other and I say, okay, together now I have 5 green pieces. The green piece is what part of a whole? And the kids can play around and say that, oh, 6 of the green pieces make a whole. So I have 5 of the 6 pieces I need to make a whole there. So next, I'm going to try to draw that. And I don't know about you, have you guys tried drawing the hexagons? Well, I guess you have. I saw some of your work. You did a good job there. So there's my share screen. Let's draw that out here. So using the pattern blocks to do this, all right, here's me drawing a hexagon. Not too bad. And then I want my, oops, I'm supposed to be blue. Actually, I'll try that again. I can do better. Focus and don't talk too much. There we go. And then I want my blue piece, which looks like that. All right, so there's my 1/3 there. And then I want to combine that with my half. It's way easier to use the app. And so on the app, I could easily just throw down that trapezoid on top of the hexagon. And we can see that, well, it doesn't quite work, so we have to redraw. And so I could draw on top of this if I want. I can say, well, let's just go for those green triangles, which would split it up like that. So now I can see that this piece that I was calling 1/3 is really 2/6, and this piece that I was calling 1/2 is really 3/6. And so when I combine and count, I have 5 out of the 6 pieces I need to make a whole. And we could draw them all together if we want. And I want to today. And so I have my 1, 2, 3, 4, 5 pieces. Oh, that was messy. And I'm just making it messier. But there's my 5, 6. And again, what's the process here? right? We have to illustrate what is a fraction. And then we have to somehow try to combine and count to get the answer. In doing so, I happen to find a common denominator. So we might make a note of that. Denominator, there we go. The question is, do we always have to find a common denominator? Good question. Let's take a look to another problem. Let's try, how about 1/2 plus 1/6? There's a lot of different approaches that we can take for this. So first I'm going to draw my pictures and see what happens. If you want to comment on this, I gladly would take comments. So I'm going to draw my holes, trying to make them as equal size as possible. Close enough for today. And like before, when I cut my half, and it doesn't matter, I mean, I could go horizontal here first. And then 6, I think what I'll do is cut the 6th in half and then cut those halves in thirds. And so I'm going to do this. And I want one of those halves. And I want only one of those 6. And clearly this is way more stark than before. They are not the same size. So I can't say there's 2 pieces. 1 plus 1 is not 2 in this case. So what is it? Well, I'm going to try the same thing I did before. I'm going to cut each like the other. And so the halves, nice and easy. I'm just going to slice through like that. And then the same process I did before, estimating where each line is going to go, and adjusting as I draw them. Sometimes I don't put the lines in the right spot. Not my best. Oh gosh, that came out bad. Bad drawing my lines at the top and just go worse. There we go. That's a little bit better. All right, so what I've redrawn here is a grid that's 2 by 6 on each of these. And the 2 by 6 represents my halves and my 6. So altogether there are 12 pieces. And I count the first one has 6 out of the 12 pieces. The second one has 2 out of the 12 pieces. Now I can combine them because they're all the same size. Altogether, there are 6 equal-sized pieces. No, I can't count. That's not 6. There are 8 equal-sized pieces out of 12 in a whole. And sometimes it's not a bad idea to redraw that. So I'm going to redraw all of those together. Setting up the grid exactly the same way. So I have my 1, 2, 3, 4, 5, 6, like up there. And then these 2 I'm just going to throw down here like that. So that's one version of the answer. Now, 8/12 is a great answer. I love it. We could be done there, but some of you are probably chomping at the bit to say, but we can reduce that. And the answer is, yeah, we totally can. And there's a lot of ways to go about reducing it. So I'm going to use the picture to try and reduce it. So when I'm looking at the picture here, what do I see? Well, let's see, I want a different color. Let's go green. For sure, I could do something like there's a group of 2, another group of 2, another group of 2, another group of 2. There's lots of groups of 2 here. And I have 1, 2, 3, 4 of those groups of 2 are shaded. and there's 6 altogether. So I could also say the answer is 4 out of 6. But there are other things I could have done. Let's undo that a little bit. We might even get bolder and say, wait a minute, can't I group them together in 4s? Like there's a group of 4, and there's another group of 4, and there's another group of 4. So if I group by 4, I could say, well, 2 of those groups of 4 are shaded, and there's 3 groups of 4 in the whole. And so then I can say the answer is 2/3. So usually there's a bunch of ways to draw the picture to regroup. And so since we grouped by 4 here, to reduce this fraction, we are dividing top and bottom by 4. And that's how we're getting 8 divided by 4 is 2, 12 divided by 4 is 3, 2/3 is a reduced answer. Questions on that one? Chat's quiet. I hear no voice. You guys still with me? Excellent. Thank you, Evan. All right, so we're going to do that again, but this time I'm going to use those physical toys, and I'm going to jump over to the app to do it. And I'm still going to do the same question. I'm going to do 1/2 plus 1/6, but I'm going to use the pattern blocks. So 1/2 plus 1/6. So let's clear. And one thing I like about the Math Learning Center apps, some of them have the share option. So you could build one of these and then get the share link and send it to a friend in class and say, hey, what do you think about this? All right, so this right here is going to be my 1 whole. And then I need to show 1/2 of that. So there's my 1/2. And then here is another whole. And I want to show 1/6 of that. So there's my 1/2, here's my 1/6. And let's see, I can even put text in here. Let's try it. 1/2. There we go, cute. Let's label this one for fun. 1/6. Now, problem is, again, these pieces are totally different sizes, so I got to redraw them. So realizing from our play earlier that the green pieces form kind of like a common denominator, I can redo that 1/2 in this way here. And these guys rotate. All right, so there's my 1/2. And I want to combine it with my 6. So I'm just rewriting the 1/2. So let's make a note here since I can that this is now 3/6, still a 1/2. I'm just renaming it. There you go. All right, so then I put them together. So let's see, I'm going to draw a little arrow. So I'm going to combine them now. And then we'll just put them in there. 1, 2, 3, what do we have? 4 of them all together. That one needs rotation. Okay, so altogether I get 1, 2, 3, 4, 6. And maybe just for fun, I'll move this one over there. So I can look at this and say, all right, looks like my answer is 4/6. And I'm done, right? Yes, no, maybe. Can I use another piece to illustrate this answer? A bigger piece?
The rhombus.
Yeah, I could throw the rhombus in there. So I'm just gonna underneath, I'm gonna draw this. Let's make a little arrow. There we go, arrow. So if I throw some rhombuses in there, I can never remember if it's rhombus or rhombi. Oh, where'd you go, rhombus? Let's rotate you so it's the same orientation. And then, oh, other one. Rotate. Okay, so now they have the same orientation as that one up here, but now I can rewrite the answer and say, oh, okay, it's also 2/3 when I regroup. Now, this is interesting. The first time I did this, and actually let me copy this to my notebook. Current page, there we go. The first time I did this, I ended up using a denominator of 12ths. And I had to reduce it down to 2/3. The second time I did it, I ended up using 6, just because that's the way the pieces came out nice. And I still had to reduce it. So I wonder, is there a different denominator I could have used so I wouldn't have to reduce this? Get what I'm saying there? Is 6 the smallest possible denominator, I guess is my question. 6, smallest possible denominator to do this addition. Well, that idea of a smallest denominator is the lowest common multiple idea we looked at before. So what is the lowest or least common multiple of 2 and 6? What do you think? Can anyone help me answer this? Evan says 12. Amanda says 12. Anyone else? So I'm just going to go back and look here, and then I'm going to remind you of a couple things. So in this case, I was using my whole halves go one direction, 6 go the other direction, then I cut each like the other. That works great. It works all the time. Not too hard to draw the pictures. I ended up with 12s as the denominator. However, with these pieces here, I didn't even have to think about 12s. 6 came up naturally, right? So 12 is definitely a common multiple, and so is 6. So it turns out 6 is the lowest common multiple, the least common multiple. Okay. So 6 is the least common multiple of these two. We had a couple of strategies for determining the least common multiple. One of which was to just list all the multiples of both of them and find the smallest one. The other was to look at the prime factorization, and 2 factors only as 2. 6 factors as 2 times 3. When we put those together to find the lowest common multiple, the 2 got to have a 2. The 6 needs a 2 times a 3, but we don't take any more than we have to. So it turns out we stop there. We don't have to repeat a 2. 2 goes into 6, 6 goes into 6. That's the smallest of the common multiples. So it turns out that is the smallest possible denominator to add halves and 6. So 6 is the smallest possible denominator to add halves, and sixths. Ah. So it is what we call the LCD, lowest common denominator. Now the interesting thing is, even though I had the lowest common denominator, I still had to reduce. And it just depends on the numerators also. Sometimes, even if you have the smallest possible denominator, you have to reduce the result. Other times, you don't. It just depends. So what I want to play with next is to have you guys practice drawing these situations and using some toys. Now, the toys that we're going to have to play with, so this is activity 5.3a. We've got the pattern blocks, and I demonstrate one, like how would I show a third plus a third? And if I use dark green as a whole, then the red is a third. And so 1/3 plus 1/3 is simply just 2/3. So that one's pretty straightforward. And then for parts B and C here, I say, okay, continue using the dark green strip as a whole. We always need to know what a whole is. How do we show 1/6 plus 1/3? How do we show 1/2 plus 1/3? And so I want you to draw that out or use the online toy to try that. Those two are pretty straightforward. It gets a little more interesting down here, playing with these here. And again, I show an example of 1/3 plus 1/3. Earlier I had 1/2 plus a sixth. Here I have 1/3 plus a sixth, 1/3 plus a half. And then part D, I get a little trickier. We're going to use 2 hexagons to make one whole. And so then everything changes once we change what a whole is. So part D is a little tricky. In part 3 here, we're going to try drawing our own squares to demonstrate things. So I demonstrate a half plus a third, which I demonstrated earlier. And then you're going to show me a third plus 2/5, 2/5 plus 3/4, 3/2 plus 2/3, and 1/6 plus 1/2. So I'm going to do one more example, and then I'm going to set you guys loose doing some of these right here to make sure you agree on how to demonstrate it. So let's do another one together before we break out. All right, let's try 3/4 plus 1/3. And I'm going to do this drawing the cakes, and then I'll do it with the pattern blocks. Let's see, can I do this with the pattern blocks? I can, yep. So what I want to do is illustrate and explain the sum here. Illustrate and explain. Why do we get the answer we get? So to do that, we have to first show these as images. So I'm going to use the square cakes. So I'm going to draw a square, next square, try to make them as close to the same size as I can, and then pick one direction for the fourths and another direction for the thirds. So the fourths, let's say I'm going to go vertical. And anytime I have an even number, I usually cut in half and then do whatever I need to next. So these are my fourths. And my thirds, it doesn't look too bad. I'm going to go the other direction. Not too bad. And then we want to shade. So I've got 1, 2, 3/4. And let's say I'm going to grab that third down there. And so we have the problem that they're not the same size, so we have to cut each like the other. And you can either redraw all of that or draw over the existing picture. And I don't mind drawing over the existing picture. So I want to come into thirds here, best of my ability, and fourths here. And so now what I've created in each of these is a 3 by 4 grid. So that means I'm working with 12ths. And you and the kids should be familiar with the area model to come up with that. And then we can see that this is a 3 by 3 area there. So there's 9 pieces there, and a 1 by 4 area shaded here. So there's 4 pieces there. So altogether, it looks like I have 9, 10, 11, 12, 13 12ths as the answer. And trying to think about that, like, do 12 and 13 have any common factors? Can I reduce this? I should probably show the answer. So let's redraw our square hole, cut into 12ths. And those 12ths come from 4ths and 3rds. And then I start putting them in, right? I have 9 there, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have 4 here. 1, 2, 3, uh-oh. I ran out of room, so I got to draw another cake. So I can also see, instead of calling it 13 12ths, I could also call it 1 and 1/12. And we talked about this a little bit last time, the idea of an improper fraction versus a mixed number. Which one is best? Which one is reduced? Thoughts on that from y'all?
I think the 1 and 1/12
Is best?
Wouldn't it be the best?
Well, it depends, it turns out. So here's the way I think about it. If I need to do another calculation with this number, it is way easier to work with improper fractions than it is to work with mixed numbers. So if I needed to do another calculation with this result, I like 13 12ths better. However, if I was describing a distance to somebody, like, hey, to get to my house, go 1 mile and a 12th down the road. Okay. To get to my house, go 13 12ths miles down the road. That second way sounds a little weird, right? When we communicate, it's more common for us to talk in terms of mixed numbers. But it turns out mixed numbers, as we'll see later, are a pain in the butt to calculate with. And we'll look at that today in next class. That mixed numbers are nice in some ways, like communicating, but they're a pain in other ways, like calculations. So it depends. Now, to the idea of reduced, they're both reduced. To reduce means that there's a common factor top and bottom, and there is no number besides 1 that divides 12 and 13. So 13 over 12 is reduced. It's a great answer. And I could totally leave it that way. So aside from communicating some distance to somebody, there's no reason I really need to change it to 1 and 1/12. So just to be clear, 13 over 12 is a simplified fraction. Fractions being simplified means the same thing as being reduced, which means the numerator and denominator have no common factors, right? That's what I'm saying right there. So to simplify or reduce a fraction just means, hey, check to see if there's a common factor top and bottom. If there is, divide it out. Like back here, we divided out 2 from 4 over 6 to get 2 over 3. Or when we had 8 over 12, I divided top and bottom by 4 to get 2/3, right? So 8/12 was not reduced, 2/3 is reduced. And so 13 over 12 is totally reduced. It's a fantastic answer. The mixed number is just different. It's not simpler, it's actually more complicated than the improper fraction, because here, right, when we say this, don't I say in words 1 and 1/12? That's the way we read it, don't we? And that and is literally a plus. So this is shorthand for 1 plus 1/12. We just skip the plus, but we say it when we read it to somebody. And so although it's nice for communication, it's actually a more complicated object than 13/12. So, and that's kind of another thing. Like we call this thing up here, the 13/12, an improper fraction. And usually improper is a bad thing in life. But here it's not. It's totally cool. It's totally okay.
Well, and I realized in my daughter's class when she was having to do like the addition and subtraction, they did make her change the mixed number into an improper in order to do that.
Yeah, and again, it just depends on the context. They're both good. They have their pros and their cons either way. And what we need to do is just be used to switching between the two to use in whatever context we need to. So as far as a best answer here, they're both great. And usually the best answer depends on, did your teacher tell you to use a mixed number or not? Okay, so I think I'm ready to have you guys play to make sure you get the right idea. The thing you're trying to show in this activity is, again, show a version of each fraction using the toys or the drawing that I asked, and then figure out how to add them, which means you might need to like trade blue pieces for a, oh, I said I was gonna do this in pattern blocks. I guess I better do that next. Okay, show desktop. Let's clear this one, yes. So if I wanna show 3/4, can I do that? Well, this guy here is a third, so that won't work. This one here is a half, so that won't work. This one here is a sixth, so that won't work either. So it turns out in order for me to show fourths, I need 2 of these to be one whole, because then the red shape can be a quarter. So you're gonna have to do one similar to this where we change the idea of what a whole is. So let's make a note. 2 hexagons is 1 whole. Let's just leave that at that. Put that up here. And then I'm just going to add another note to this underneath. 1 trapezoid. Oops, 1/4. So we got to reset our brain here for what the whole is. Things got mixed up. There we go. That's fine. And I want to show 3/4, so that means I need that rotated. So here's my 3/4, and then what was my other number? 1/3, right? Okay, so here's my next whole. All right, let's see. How do I show a third here? Well, this was a third before, but now what is it? The blue piece.
One-sixth.
It's 1/6, and so to show a third, I would need to put 2 of them in there. So let's line that up. Actually, let's put it over here on this side. So my claim is that right there is 1/3, and I'm just going to do a little extra play just to confirm that. How I want to do it. You over there, you rotated. Okay, this will show what I want. So when I take these 2 blue pieces and put them together, anybody know what that shape is that the 2 blue ones make? It's got a special name. it's called a chevron. So that shape right there is called a chevron. And in the whole that's 2 hexagons, I see 1, 2, 3 chevrons, right? So again, there's 1 chevron there, there's another chevron here, and there's a 3rd chevron here, and they're all the same shape. So 1 chevron is a 1/3 of the whole. Let's see, how do I get rid of those? Like that? Oh yeah, look at that. All right. And I just want 1 of those. So you go away and you go away. So here is, let's see, let's put that note down there. So 3/4 is there. And this is my 1/3 over here. Now, to put them together, I got a problem because they are all different shapes. And so what is common to build these? Well, I think the only thing I have common is the green shape. So then I would have to rebuild everything with these green shapes. Oops, I did not do a good job there. There we go. So we rebuild, placing everything with greens, which is sometimes a wee bit tedious here. Duplicate button, what's that do? Resize. Some of these have duplicates. Duplicate, there we go. So I don't have to rotate it again, I can just duplicate it. Well, that's easier. And we have to do the same thing over here. That one duplicated. Okay, so I just redraw them. And so now the 3/4, I'm going to say is the same thing as 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. And the 1/3 is the same as 1, 2, 3, 4 twelfths. And so altogether, I have how many twelfths? 9, 10, 11, 12, 13 twelfths altogether. So that's my sum. Put that over there. I can draw in an equals. And we're going to quickly see that we've got a problem because when I try to put all that together in a whole, they're just not going to fit. And we realize that, oh, this is more than a whole. And we definitely want the kids to play with this and realize not just that it's improper, but it's more than a whole and how to describe it as more than a whole. So I'm going to have to come down here, another whole. And so then we can look at it, and with the kids, we can say, oh, okay, so it's either 13 twelfths or it's 1 and a 12th. So I can modify my answer a little bit there. Other things I want to do related to this, and let me snapshot that into my notes. Oops, wrong page. Is the idea of relating how is the 13 twelfths related to the 1 and 1/12. 13 twelfths versus 1 and 1/12. So I know there's 12 pieces in a whole, and 12 goes into 13 once with 1 left over, right? So here's my 1 whole. Oops. this right here is my 1/12 left over. The idea of converting back, we'll talk more about that later. So converting from an improper fraction into a mixed number, we just divide. Sorry, improper to mixed number. When we want to go the other way, the key there is that 1 and 1/12 is really 1 plus 1/12. 1 is 12/12. And so now we have 13/12. And there's usually a shorthand, right? We talk about where we take, oops, I'm missing a digit there. Where we do a multiplication, and then we do an addition to make that numerator there. Okay, I think I got everything I want to go over for the moment. I want you guys to play a little bit more. So what I want you guys to do is check some answers. So for example, I show part A. Part B, you would need to do. So check with your neighbors on that when I put you in groups. For part 2 here, I did part A for you. And then let's see, we already, did we do? No, we didn't do that one yet. We did that one. Yeah, so in particular, you want to do check B and D with your neighbors. I already went over C at the beginning of class. And then here I have a few different ones that you want to try drawing yourselves with the squares. So I'm going to give about 15 minutes to work on these together, and then we'll reconvene and talk more about addition and then a little about subtraction.